Okay, good morning, everyone. Today we start doing some experiences of machine learning over PySpark environment. Similar to your previous experiences, first of all, you need to know how to import the data, understand the data. Probably you need to have some background knowledge. You do train, you evaluate uh, your trained models. You get some insights. Either could be having a high accuracy prediction or finding the most relevant variables that are associated to outcome, and you provide feedbacks. Either could be used for future prediction even. So let's clarify what we had so far. So we learned about big data concept. What does a big data mean? What's its differences from the previous traditional data sets, either in terms of types, volume, speed, and other characteristics. Then we learn about some big data infrastructure, uh, the importance of resilient parallel processing. We have seen that having a large computing center may not be economical and also may not be safe and secure. Is much more convenient and reliable if you have multiple processing clusters that work together. Then we talk about big data methodology, especially MapReduce. We had some experiences of doing MapReduce through Python. Then we started to learn about Hadoop ecosystems and some technologies within that ecosystem. The one that is most relevant and probably in future you might have more usage. So from now, we mostly focus on the red side, especially learning how to do code in PySpark environment, doing some analytical projects using machine learning algorithm and get some insights. So far we had some small experiences to get to know Hadoop HDFS, what does Yarn do, doing some MapReduce, and working with the SQL-like pig script for managing the data and making some queries. In the next classes, hopefully if you have time, we do some scoop. So we learn this technology, how to import the data from other data sets into Hadoop ecosystem. But let's see what challenges we might have. First of all, do you have any questions so far, even from people over Zoom? I think it's better to do this, because if your friends have questions, I cannot see them. So let's do it this way, because I don't see the chat box if they ask some questions. So let's see what the challenges that you might have. This is common in any like computer science, data science, and analytics field. First of all, the learning curve might be tough, but hopefully it's your third semester, you already have some SQL, Python, or other platform experiences. So it shouldn't be too tough from now. Continuous updates, new technologies and new methodologies might come. So companies might introduce their own Hadoop flavors on top of Peak, Hive, or other technologies. Some similar technology would come, but you need to keep yourself updated. Also, from methodologies, we talk about MapReduce. Maybe there's some updates in them. Also, in prediction part, on top of linear regression, neural network, bagging, boosting, some other technologies might come. So many technologies, or even here you can see some programming languages. So Python, R, JavaScript, Python, Pig these are among the ones that I mostly use them. If in future, most likely you just work with one or two of them, but no worries, if you're good in Python, probably learning R doesn't take more than a couple of weeks. Or Java and JavaScript is a different style of languages, might be challenging anyway. So you might end up using some community-based developments like Apache Hadoop. So you might end up having some problems, bugs, or issues that you need to ask from community, or you help your friends or your community either through GroupMe or some platforms like Stack Overflow. Commercial platforms, even they have their own challenges, like drastic changes, suddenly they stop support. It could be expensive. Some companies do certain policies and merger acquisitions, like Horton was acquired by Cloudera, or even for me in the teaching side, I wanted to teach you some of the Hadoop ecosystem through Cloudera, but they suddenly stopped supporting. Or when you do tunneling, in your previous experience or even assignment, you should do tunnel to AWS to run Jupyter Notebook on your browser. So if you Google it, sometimes it might be challenging because they had some changes in the settings, and so it might bring some challenges for you guys. So anyway, they have their own business, and you might see, even they might get bankrupt, so they may not offer their service anymore. So, but what are your certain challenges in this course? You know, most likely most of you are in the average in terms of skills, but some of you are highly skilled because they have high skills or trained before because of their background or their work experiences. Some of you might come from different backgrounds. So both of you guys are in the extreme high skilled and different backgrounds should do extra works. For the people who are highly skilled, you might do some extra like some extra project as a bonus, which usually I consider a bonus, so you can entertain yourself. So the people who are from different backgrounds, they should do extra thing to keep up with the most of the class. So the two extreme might do extra works. You should, and at the end you shouldn't tolerate it. It could be your work in the rest of your life. You should do it in the way that you enjoy it. So these are some example of extra work. For example, in the previous class we did tunneling through AWS. You can do through Google Cloud. In some startups, which one of your friends is working, you can run your startup and apply grant through Google and get the computing resources from them. But you should read the contract very well. I'm not talking about Google, but usually when those companies provide credits in the like several pages of contract, they put some terms. They take out a big portion of your interest. So just keep in mind, if they do give you credits, they are targeting some advantages in future. But if you need some cash to run your startups, maybe they have good offers for you. Or you can install PySpark through your local system, do that. You can help your friends get some bonus over GroupMe. Or for the people who are in the lower bound, which is from different backgrounds, they can do some extra work, like reviewing data camp courses that we have, like Introduction to Python, Intermediate to Python, or through Coursera or edX, you can review some Python or SQL, some short courses that you can learn in a couple of weeks and keep up with the rest of the class. So any questions? So people who are over Zoom, you can ask your question either texting me or use your microphone. By the way, at least one of your friends could get the AWS credit, a student credit by applying to AWS Educate. I assume rest of you should do. And last year, like a couple of years ago, I was a student I could get by myself. I was thinking maybe they canceled it, but one of your friends got the $100 credit. So I assume the rest of you can do it too. So let's talk about the general data mining or machine learning process. First of all, there is some general standards that talking about the overall process that you need to know to do. There is some similarity between all of them, but they are looking at the process in different ways or from different angles. The most common standards are CRISP-DM, Cross-Industry Standard Process for Data Mining, SEMA, Sample Explorer, Modify, Model, and Assess, KDD, Knowledge Discovery Database. So CRISP-DM must look at this in the angle of developing a data mining project. SEMA is mostly for looking at the practical angle, and KDD is mostly look at the knowledge or inference that you can get from your process. But at the end, they're talking about similar steps. So these are steps in the CRISP-DM standard, which is most likely in your project, you follow these steps. First, you need to have some business understanding, some background knowledge what your data is about. Data understanding, you need to know your columns, what those if you are using a data frame, which I expect most of you do that. So in data frame, columns refers to variables. You need to understand what those variables means. For example, I had a project in predicting survival chance of patients. One of the column was G2. So I didn't just dump my variable into model. I look at the columns one by one. I understand G2 means patient's weight. And when I look at that, I had some weights that didn't make sense, like an adult with a 5-pound weight. So it's nonsense. So you shouldn't see an adult, or 10 pounds even. We don't expect to see an adult with such a low weight, or some of the weights are crazy high. So although you can look at the outliers by formula, you can sometimes they don't pick by formula. You can just pick them by your understanding. Data preparation. So you might have some observation or columns that you want to drop, or you do imputations. You have empty cells that you need to impute. You don't want to simply drop them. Just an example of bias algorithm. Let's say you do a survey as your female observations didn't fill out some certain observations. So if you drop those observations that related to the female ones, you don't have that much of enough observation for the female. So when you train a model, maybe your model would be trained very well for the male, not for female, because in the data preparation part, you drop so many female observations. So data preparation is important. Then the next step is model building. Basically, you use a algorithm, machine learning algorithm to train over your data. In test and evaluation, you look at the performance of your prediction in a train and test set. And deployment means the future use. Like if you remember, we talked about holdout set, which refers to a random data set that comes in future. We want to use it for future use. So if it's about patients, using to predict survival of new patients. In the stock market, using to predict the next day stock price. As you see, this is a cycle. So you start from business understanding, then data understanding, then you go up to the test and evaluation. Maybe your performance is not great, you have overfitting. So can anyone remember what does overfitting means? Okay, is a one definition could be. So any other idea about what does overfitting means?
Basically, overfitting is when the data, when you know that when in the data there is not getting the right word.
That's okay. I mean, it happens. No worries. Yeah, I mean, it's kind of looking at the like too much of noises and you don't fit very well. But the general definition is you train very well over train set. Let's say performance of prediction train set is 90%, but when you use test set, it's like 80%. So there's a huge gap between train and test, means you overtrain your data on the train set, but you cannot generalize it for testing. So it's the reason is a cycle. We go back and forth. For one of the ways that you can avoid overfitting is doing feature selection. So instead of using too many variables for a model, maybe a smaller portion of variables, and you might have a more generalized model. This is the overall process of SEMA. Still is a cyclic format, and KDD as again you see feedback. Feedback means you develop your model to you end up getting evaluating, but maybe it's not that much great. So you go back and again maybe change some parts and train a better model. Publication wise, ChrisTM is the most cited algorithm. Most likely it is a well suited for the project-based project, which people usually end up publishing them. SEMA, KDD are other algorithms, like standards that people mostly use. Again, as I provided some examples, the data preparation is an important step. And it's one of the reasons that people pay you as a business analyst. They want you guys to just explore the data, don't just dump it in the model. So if you're the one that just dumped all of the data in the model, they don't need to hire you. They can hire high school students to just do similar thing. So any questions so far? So next assignment, I already posted on your Moodle. You have due date is October 14. Basically, you do some experiment of data frames through PySpark, and you can do it over Databricks. But if you can challenge yourself to do it over AWS or Google Cloud or local instance, if you install, and you can report it as just a notebook with the result, or you can take pictures, attach it to a Word file. Just provide me some evidence that you did the assignments. That should be more than enough. In the next sessions, we focus mostly on machine learning library or MLlib of Spark. We work with the data frames. As I said, there is two formats of data that people use in the Spark, or in general, there are RDD-based format, which is a more traditional ones that is getting obsolete. The other one is data frame, which is more intuitive, and there is rumors that sooner or later MLib would, data frames would replace RDDs. But if you end up working in the company that they are still working with RDD format, there is a good documentation in the link that I provided. But for this class, our focus is in the data frames that I expect to be a state-of-the-code format in the future. So if you click on the link or just copy and paste on your browser, you end up getting this website. So on the left side, you can find a good documentations of MLlib, like how to work with the data sources, some basic statistics, classification and regression. But if I go down, like binomial logistic regression, as you see, you can see codes in Scala, Java, Python, and R. So if you're hard R coder, you can still use your knowledge here. Good examples, and you can just follow. So for your project, you might just come here. One of the ways that you improve your performance in your final project, maybe using different models. Look at here, they have decision tree. Maybe instead of random forest, so you can, one of the ways to improving using different models. For today, I'm focusing on logistic regression here. But as you see, there's so many algorithms. Sorry, today we focus on linear regression, which is the simplest one, and you already exposed to your statistical courses. And but at the end, we cover more algorithms, but you might use other ones. Just come to this page and find different types of models, and you can easily just apply those models for your final project. So what I expect from you, so it's similar to your previous course. In analytics programming here, you need to do some analytical project. You do everything from scratch, importing data, understanding data, up to prediction. Based on your project, you might focus on important variables, might be a healthcare project, or like if a finance project, maybe you need to predict the next day stock price. Look at we focus on the performance. But you should try, even if your accuracy is 95%, you should try at least 2 other approaches, either using different algorithms, doing feature selection, or different imputation. You should try 3 different ways and try to improve your performance. Maybe you couldn't, that's fine, but you should at least try different approaches. And these are for RDDs. So we already had the experiment of working with RDDs in one of your sessions, and you can see how to work with them here. But again, it's not our focus for the class. Our time is limited. If you have extra time, maybe I do some RDD, but again, it's getting obsolete. So our focus from now, at least for next couple of weeks, doing some machine learning project from this documentation and getting some insights from that. Any questions? No? Okay. So, okay, in the labs 7, we do have a simple machine learning project which our experience is about linear regression. So in linear regression, we have a dependent variable, y, but here we call it label. And we have some independent variables, but the technical term today is features. So right side, features with their coefficients, left side, dependent variable or label. You might remember that there's a test of hypothesis for linear regression. H null is coefficient of 0, which means you have a parallel lines to the x-axis. So, oops. So H null is all of the slopes or beta that you see here are 0. What does it mean? You just have an intercept or C. If you have just intercept, you mean you have just a line parallel to your x-axis. Alternatively, we want to see the coefficients are significantly different from 0, or you have something like this red line that fits over your data. So again, otherwise we have a H null, again, is a line which is equal to mean of all of your observation and is parallel to your x-axis. Again, this is a two-dimensional problem because for us as a human, it's easy to visualize it, but you might have more than 2 dimensions, 3, 4, 5. So for today's experiment, log in from this link. You can log into your Databricks account. And for today, we want to work on some Jupyter notebooks that I posted. Let me show it to you guys. I give you a couple of minutes to go to your Moodle, download either Python Jupyter notebook or HTML notebook, so you can copy and paste the codes. Also download the sample linear regression data.txt and web_sale.csv. Download all of them, and I give you a couple of minutes to do that, and then log into your Databricks account. Okay, first step, similar to Amazon AWS, is running a cluster. So on top of that cluster, we upload the data and also run our codes. So on the left side, go to the cluster and click on the cluster icon. I already have a cluster, but let me just delete it. Here you don't get charged, but in Amazon, or Google Cloud, you should keep in mind that just turn off your cluster. So again, click on new cluster, just pick a name, then be sure Spark 3 is selected and click on create cluster. So if you look at my cluster name, which is class, there is a loading, so it might take a couple of minutes to be loaded completely. Okay, if you look at the next to my cluster name, now the green dot means it's loaded completely. So I wait like 1 minute for rest of you. For you might take a little longer. So, but when you see this sign, the green circle or disk, this green disk means you are able to load your cluster. Okay, next step is importing your data over the cluster. Again, please remind these steps. So next classes, I don't just do a step by step. So go to the data, select add data. So here, just drag and drop your data set. The first one is sample linear regression data.txt. The next one is web_sales.csv. Just drag and drop them in here. Okay, after you dropping them, do you see these two addresses here? These are your file addresses that you can use it later to work with them. So the location of your file over the Hadoop ecosystem. That's it. You don't need to do anything else. After dropping them, go just to this icon on top, left top, and click create new notebook on the left. You can click on it. Just put a name like linear regression. Be sure that you select Python and cluster. You should select the cluster that you use. Again, if you think it's convenient for you to work over Google Cloud or Amazon AWS, you can do similar thing over there. You need some more extra steps. Then you click on create, and you create your Jupyter notebook. On the left side, from you need to specify your cluster. Sometimes automatically pick. So here, click and select the cluster that you created. Confirm, and now the cluster attached to my Jupyter notebook. I already did it for this class, so let me open mine. So the first few blocks is similar in almost all Python projects. For example, we import export session, also importing random, which I explain later. Also, we create an app. Again, since our data is very small, maybe you don't see any application app here, but it's a good practice. Later, you can use the app to see what is going on while you're waiting for a large data set to be analyzed. Then from PySpark ML regression, I'm importing linear regression. So this is what we are using for today. Next step, I need to import my data into PySpark environment and work with that. But just before importing the data, let me click on the sample underline linear underline regression underline data.txt. As the format looks kind of weird, it doesn't look like a traditional column and row data frame. This is in the libsvm format. This is the format that is PySpark friendly. It's not that much great for human, and I explain later. So it's the reason for the input. I'm saying that the format of data is in the libsvm, and I'm loading from this address over my Hadoop ecosystem or cluster that I'm using. With data.show, I can see what data I imported. As you see, it has two sections. First section is label, which is my dependent variable. The right part is features. Features here is just one column, but actually it has several variables and columns that are merged into one column. This is like PySpark friendly, and for human, it doesn't seem great why all of the columns are merged or consolidated in one column, but this is just the format is more comfortable or convenient for PySpark. Later, we worked with the human-friendly format, but here I just wanted to show you how does this format look like. I give you just 1 minute to copy the codes or just play with them a little bit. Let me see your friends first.
And I have to upload on the group. The data type.
Okay, look at here. I'm calling random.seed 111. So the process of splitting your data in train and test and the algorithm that you train, all of them are random. So each time that you run the model, your result is very close, but there is a randomness associated. So your data might be a little different each time, your outcomes. With specifying a random seed, every time you get exactly the same result. So then over the data that I imported, I'm calling random split method to split my data in 70 and 30%, 70% train set, 30% test set. In the next step, I'm making an empty object of linear regression, which later I import data in it. So as you see here, the structure of my linear regression, it has the feature column, which is consolidation of my independent variables, has name of features. Label column, which is my dependent variable, is coming from label column. And also I'm doing a prediction. In the next block, I'm fitting that linear regression object over my train set. And I assign the train or the fit train model to variable of all lreg fit. So I want to see what I did in terms of coefficient of the prediction and also intercept. So I'm making a pattern with the print command. So I want to type or print model coefficients, and the format would be coefficients of linear regression model that I fitted over my train set, with print/n, it just go to the next line. So as you see in the result, there is a space between two prints because print/n just print an empty line. And next line, I'm printing the intercept. So this is my model. Look at there. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 coefficients or betas, and this it would be my intercept. But let's see how's the performance of my linear regression over my train set. So with summary method, I can look at the summary of the prediction that I had over train set. For example, with residual.show method, I can get the residuals. As you see, pretty large actually, negative 28, 25, minus 24. So now I can, since it's my label variable or dependent variable is a continuous variable, the performance, there is some performance measures that you can use, such as RMSE, which stands for root mean square, and also R square. So I'm printing this pattern for RMSE and second one for R square. Look at my RMSE, 10.12 and my R square 0.05. So do you think it's a good model or a bad model based on the RMSE and R square? Why? Yeah, R square is really low. It should be between 0 and 1, and if it's close to 1, it's good. Yes, you are very right. So again, you might see something similar in your final project. You might do prediction and it doesn't seem good. I expect you to try 2 different ways to improve your performance. You can use another model. You can add new observations. Maybe number of your observations is too low. Or you can synthesize new variables, like you can make moving average, or let's say instead of x1, you use a natural logarithm of x1 or x1 squared or raised to power of 2. So basically you can synthesize new variables. Or feature selection, you have 10 variables, maybe you can reduce number of features to have a better model. So it was our performance in the train set, which is terrible. Let's look at the performance of prediction in the test set. So with evaluate method, calling over the prediction object that we fit over train set, we import test set to evaluate the performance of test set. It's our residuals. It's pretty large. And let's look at our RMSE and R squared. So this time we do over test set. As you see, R squared is still high, 10.46, similar to train set. Look at R squared, this time is negative. It's not only too low, but also minus 0.08. So in test of hypothesis, we test either the slope is 0 or is a parallel line to the x-axis, or there is a slope. Sometimes your model is too bad that even the simple mean of dependent variables or y's, which is a parallel line to the x-axis, let me show it from here. If you did terrible job and your R square is negative, it just means this orange line is better than the line that you use for prediction, the linear regression line that you created. This means a very bad prediction. Even if you didn't do anything, just use a simple mean of all of the dependent variables, your prediction was better. So probably your data doesn't follow any any linear relationship, so might be the reason you have such a bad performance. So with the transform, you can see the prediction using the model that you just developed. Prediction is an arbitrary name. You can change another name, but at the end, it add a column with the name of prediction that shows how you predict your test observations. Okay, now we want to import a CSV. It's a more intuitive data format for human because it has columns and rows, and the features are not merged or consolidated in one column. So with the read.csv method, I'm importing my webs underline sale CSV. I'm saying the schema is equal to. It means I ask Python. I let Python to guess the format. Also, I'm saying header equal to means there's a header in my data. I'm also printing the schema. As you see, the schema that Python guessed is pretty good because I have email and address column and avatar. All of them are a string, and the remaining are numerical value, which is in my schema they are double. Again, it's good. I don't need to change the schema, but in your assignment or previous class, you have seen the how we can change the schema if you don't like it. Anyway, in this data set, we have some customer information, email, address, avatar, when they have average session length on the website, time on the app, time on the website, length of membership, and year amount spent. So based on the variables that we have here, we want to predict the last column, which is amount of the amount of money that they spend annually. So I give you a couple of minutes to work with the previous code. If you just behind, you catch up with the class, then we use this data set to fit a new linear regression. Any questions? Again, for this exercise, we want to predict a yearly amount spent column using the previous column. Some of them are string, probably they are not useful. We want to get rid of first three columns. Again, this data is in the data frame format, is human friendly. We need to convert it to Spark friendly. And so Spark could be able to use the data for training the model. So first step, get rid of the first three columns. Second step, merging the four independent variables in the one column to be make it available for Spark to fit the linear regression. Okay, for merging the four independent columns that are numerical, we need to import these two packages. So from PySpark ML LINAG import vectors, and also from PySpark ML.features import vector assembler. If I call columns over my web sale data, I see the column names. Here I'm defining the structure of consolidation. I just want to use average session length, time on app, time on website, and length of membership. Use this one to merging my data into features column. So with the transform, I'm using this structure for merge consolidating. And when I call show method on top of the data, you see now I have a feature column, features column that is hard for you to read, but basically it's just a consolidation of the other independent numerical columns. So we just did format conversion, no mathematical behind of it, just we convert in the way that easy for Python to process. So if I want to predict yearly amount spent, now I can just use feature column, because feature columns has the information of the other four. So as you see here now, from that data set that I have, I'm just selecting features and yearly amount spent, because it's the only one that I need. And also on top of that, I'm calling the random split method to split my data 70% to train and 30% to test. And now I have train set and tested data sets. So first of all, I need to define the structure of my linear regression. I'm just saying that, okay, I have a linear regression object which feature columns, or my dependent variable is under features. Sorry, my independent variables are under features. Label column, which has my dependent variable, is yearly amount spent, and I'm doing a prediction. I'm fitting the object over my train set here. So let's look at my coefficient and intercept by calling coefficient and intercept filtering with that. So I have four coefficients because I merged four columns and also one intercept. Now I can look at the performance of my train set. These are three different performance measures: RMSE, MSE, and R squared. I'm calling all of them. So by calling summary method over the linear regression object that I created, and calling root mean square, mean square error, and R squared. So as you see, my RMSE is 9.9, MSE 98.74, R squared is 0.98. It's pretty good. So it seems we are satisfied with performance in the train set. Now we should look at the performance over test set. first of all, both of them should be high and close to each other. And if there is the drastic difference between train and test, it just means you have overfitting. You cannot generalize your model for any new random data set. Again, with evaluate method, we check the performance over tested, and like by calling residual.show method, you can see your residuals. Also, let's look at the three performance measures. So R squared over tested is 0.98. It's pretty close to the train set. So both of them are high and close. No, very good accuracy. Also, no evidence for overfitting. On top of that, with what by calling transform method, we can predict using our test set. And as you see now, I have a prediction column next to yearly amount spent, which has prediction of my linear regression. There is some differences between yearly amount spent and prediction column, but I don't see any drastic differences between the actual one and the predicted ones. Next step, even if your performance and prediction is good, I expect from your final project to do some try and error to improve your performance. For next step could be adding more data, either observations or you're synthesizing new columns. If it's time series, you can even do moving average, but here you can't because it's not time series. Maybe you can do, what you can do is doing natural logarithm of some columns or a square root of them if the relationship is not linear. Maybe you can do n-fold cross-validation, like 5-fold, 10-folds. So on top of checking the differences of train and test set, you can also check the differences of performance, prediction performance over each loop or fold to see if they're close enough or not. You can use other models or better models. So here we use linear regression. Maybe we can use SVM for regression. See if you can have better results. Feature selection. Maybe you have 4 variables here. You synthesize 10 more, 14 variables. Maybe you pick 5 of them that has the best performance. So feature selection is another approach to have a better model in terms of not having overfitting. So we use feature selection to avoid that. Tuning the algorithm. So maybe you can change some parameters of your algorithm, like in neural network, maybe you can change activation function. Resampling, like if it's a classification problem, again, I'll go back to the female male example. So let's say your observation is too low for female, maybe you can use some resampling algorithm to synthesize new observations or resample them and to have a model that is good for both genders and other steps. So you can just really find different ways that you can improve your prediction. So from the next session, we try to use some of these approaches. Maybe we can try n-fold cross-validation. Maybe we can do feature selection to have a better model. Any questions? Okay, I have a question over Zoom, I guess. Yeah, one of your friends responded that the R square was really bad. Thank you. Yes, you're right. Sorry, I didn't see your answer. I'm so sorry. So sometimes if you use your microphone, I can faster find you. Sometimes the notification even come late. Okay, questions from people over Zoom? Okay, so if there's no question, that's for today. Have a great rest of the day. Thank you.